Okay, 2.6 and 2.7 I combined because we're talking about algebraic proofs and segment proofs. And we introduced all these properties that we are familiar with. The first four are just your basic property used in algebra. And that if you add something on one side, you have to add it to the other. Same as subtraction, same as multiplying, and same as dividing. Distributive property is something we're familiar with. And now we have a few new ones in geometry. The reflexive property is just when you say something is equal to itself. Symmetric lets you say, hey, if A equals B, then B equals A. Basically, it lets you switch the order of the equal sign. Transitive says, hey, if A equals B and B equals C, then A equals C. Substitution says, hey, if A equals B, then B can replace A in any expression. So we can actually plug in A for B in another expression. So these are some properties that we're going to use as we go into doing some proofs. Here's an angle proof that we're going to do real quick. There's actually a typo here, so I'm just going to cross it off. So let's look at what we know. We have angle K and M and L, and they make up angle K and L. And they tell us that NM bisects angle K and L. So this is a bisector. Well, how do we know that in our statement? Well, that's just given. And whenever something is bisected, that means it cuts it into two congruent angles. So we could say that angle K and M is congruent with angle M and L. And that's just the definition of an angle bisector. And since these are congruent, we can also say that they're equal, and that's what this statement was supposed to say. So I'm going to zoom in and put it in blue right above. So it should have said that the measurement of angle K and M is equal to the measurement of angle M and L. Okay, and now since we know that the measurements are equal, we can just plug them in. M and L is 4x, and K and M is 2x plus 40, so technically I should have switched this order, but that's okay. So they're equal to each other. We know that. What lets us just plug something in for its equivalent? Well, that's the substitution property. Substitution. Property of equality lets us just substitute in something for another thing as long as we know that they're equal, which we do according to this drawing up here. Okay, well, if we have these two things equal, now let's go about solving this equation. I think my next step would be to subtract 2x from both sides. Now in a proof, we're not going to write the minus 2x here. We're going to just write the result. So if I was to subtract 2x from both sides, I'd be left with 2x on the left side and just 40 on the other side. And it's the subtraction property of equality that lets me subtract 2x from both sides. And then I'm going to divide both sides by 2, and I'm left with just x equals 20. And that is the division property of equality. And yeah, I just use the math symbols because it's just nice little shorthand. And that's fine by me. Okay, so there we go. I've found out what x is, and I've proven it actually. So I have all my statements of truth here and all my reasons for each of those statements here. And so I've actually proven that x equals 20 in this situation. So let me do one more for you. This is with a segment. Something happened with the document where it pushed everything over. So this is A, this is B, this is C. AB is 4y minus 3, and BC is 2y plus 1. And given AC equals 46. Okay, well that's true. AC equals 46. How do I know that? It's just given, right? And what else do I know is true about this? Well, I know that AB plus BC has to equal AC. And so that's why I write that down next. And the property or postulate that lets me say that is the segment addition postulate. Okay, we've done a lot of problems like this, and this is usually where we start, right? I told you to write out your geometric equation or the segment addition postulate. So let's plug in what I know. Well, I know that AB is 4y minus 3 plus BC, which is 2y plus 1. And the whole thing just equals AC, which we already know is 46. And so what property lets me plug those things in? Again, that's the substitution property of equality, right? I know that these things are equal, and so I can just plug them in. All right, well now I have this equation here, and my first step is going to be to combine like terms. When I do that, I would end up with a 6y and a negative 2 equals 46. Now, for the sake of the proof, when I combine like terms, I just call that simplifying. Okay, what would be my next step to get that y all by itself? Because that's really what I'm trying to do. I'm trying to solve for y. Well, I would add 2 to both sides, making my result 6y equals 48. And since I added to both sides, that's the addition property of equality. Remember, so this reason here is always going to be what step I took to go from the previous step to the current step. That's what this reason represents. So likewise, the next thing here is the division property of equality, right? So what step would I take to get from here to the next step? It's going to be division, and I'm going to divide both sides by 6. And that'll leave me with y equals 8. And there, I've solved for y, but I've done it in a proof. So I have all my logical statements here, and my justifications or reasons for all those statements here. It'll probably be a while before you get really comfortable with these, but it's basically just working out all the math on one side, or all the statements, logical statements of truth, I should say. And on the right side, we have all of our reasons or justifications for those. Okay, I'm gonna go to the next page, and I want you guys to try this one. It's very similar to the one we just did. I want you to try it on your own, see what you come up with, and use the previous one as a model. So I'll pause the video, and then I'll put the answers up there in just a second, but try it on your own first. Alright, here's what you should have had. Plug in the given information first, which is AC equals 59. Then you use the segment addition postulate that says AB plus BC equals AC. Then you're going to plug in what you know. And we do that because of the substitution property. And then we simplify that. And then we add 1 to both sides, getting just 6x equals 60, so we use the addition property of equality. And then we divide both sides by 6, giving us x equals 10. And that's the division property of equality. So that's what you should have there. Alright, let's move on. As well as these being properties of equality, these are also properties of congruence. So it's important to know the difference. And the main difference is just, hey, look, these have congruent symbols, and the other ones have equal symbols, or equality symbols. So that's really how you tell whether it's you're using a property of congruence or a property of equality. Just what symbol are we using? So for example, here, I have xy equals xy. It's the same thing equals the same thing. So that's just going to be the reflexive property. Or not equal, sorry, it's congruent to the same thing. And it's a reflexive property of congruence because they're congruent, not equal. On the next one, I have if the measurement angle A equals 45, and 45 equals the measurement angle B, then the measurement angle A equals angle B. This is just like the transitive property, but notice it doesn't have congruent symbols here. It has equal symbols, right? So this is not the transitive property of congruence. It is the transitive property of equality. So just important to be able to see the difference there. Okay, I'm going to do one more proof for you guys, and this one is an actual geometric proof. So here we're not solving for anything. We're actually going to prove that PR is equal to QS. So that should be my last statement here. I'm going to start with my given information, which is just that PQ is equal to RS. And my reason for that is given. And then what did they do here? So I started with PQ equals RS, and I still have a PQ and RS, but it looks like we added a QR to both sides. And what property lets me add something to both sides? Well, that's just simply the addition property of equality, right? Alright, the next thing it says we're going to use the segment addition postulate. So here's what we're going to do. Because I have PQ plus QR is equal to QR plus QRS, or QR plus RS, what else is PQ plus QR equal to? Well, let's take a look. PQ plus QR is also equal to PR, right? Because PQ, QR, the whole thing is PR. So I can say that this thing is equal to PR. And then also QR plus RS, that's also just equal to QS, right? That's the whole thing. So I can say that's equal to QS. The reason why that's important is I have this statement of truth right here, that PQ plus QR equals QR plus RS. Now let's plug it in. Well, PQ plus QR is also right here, and it's equal to PR. So instead of PQ plus QR, I'm going to substitute in PR. And instead of QR plus RS, I'm going to substitute in QS. And so that's just the substitution property of equality. So PR equals QS. Look, that's what I was trying to prove the whole time. So it's going to take a little bit of practice. Look at a lot of examples. If you're stuck, cheat a little bit. Look in the back of the book. See if you can kind of understand on the logic that they're picking up on. It takes a while to really get good at these, but all that we're really looking for is some process for which we can see the logic flowing in these statements to prove exactly what they're trying to get us to prove. So give a couple of those a try. What I want you guys to do for your summary is just describe in your own words what a proof is and what the process involves. Okay, see you guys in the next video.